Hello and welcome to the fifth video of this DSA problem solving series. Today is morning for a change, and today we are going to start with a new topic, stacks. It's a very easy topic per se, but so we'll do one question of it, and I have purposefully chosen the question so that it covers not just stacks but a little bit more because DSA, what is DSA? It's just patterns, right? Once you get familiar with certain patterns. If it's your first time, your mind will get blown away. But if you get familiar with that with those patterns, then you'll see them within a matter of seconds. So this is one such question which makes us familiar with the pattern. And once we get familiar with the pattern, then it really helps us a lot, and uh, we treat it like it's no big deal. So let's get started. Okay, so this is the question, daily temperatures. So let's give it a day. So given an array of integers temperatures represents the daily temperatures. Return an array answer such that answer of I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer I equals to 0 instead. So what we need to do is that we have been given with this array, say. So we need to find out after how many turns or after how many indexes is a temperature coming which is greater than the value of this temperature itself. So for 73, it's 74, so 1. 74, 75, so 1. For 75, it's not 71. 75 is greater than 71, greater than 69, greater than 72. It's less than 76. So how many places is it? 1, 2, 3, and 4. So for 75, the answer will be 4. And so on. For 71, it will be 72, so 2. 69, there is 72, so 1. For 72, there is 76, so 1. For 76, there's no temperature warmer. And in that case, what do? We return the answer is 0. So we put 0 here. And then for 73, because it's the last element, it's not possible for any other temperature to be greater than this because there are no other subsequent temperatures after this. So we return 0 there as well. So I hope the question is clear. Let's hop onto a board and see what can be done. Okay, so I have presented the board. Uh, Let us look at the question. So let us see. Let us ourselves take some array. Hmm. Let's do it in Celsius. Why not? So, okay, so these are the temperatures and what will be the results? 35, 40. So 40, 31, 25, 40. So 3. For 31, it will be 25, 40. For 25, it will be 49. 1. For 49, let's know the temperature. And because this is the last element, we know that it is de facto the answer, it is 0. Okay, so the question is very simple. Let's discuss our approach here. And so this is the array. So how do we get the idea that this might be a stack question is because these temperatures, we need to push them in the stack and then we need to traverse through this array. And then whenever a newer temperature comes, we need to see whether that temperature is greater than this temperature in the stack. So let's traverse it once and let's see. So let's say we have pushed 35 in this stack. And now we traverse the array. So we go to 30. And then we see is 30 greater than this temperature over here? Is it greater than 35? But it's not. So we push 30 back in the stack. Now we go to 45. Is this 45? Is it greater than 30? Yes, it is. So we pop this 35 because 45 is greater than 35. So we pop it and then we will produce a mechanism to store answers. But this is first to see the approach. So we pop it out and then we have 45 here instead. And then we look at 10. Or do we? No, this is very important. We don't have to check just the topmost element of the stack. We need to go through the whole stack if it's greater than the topmost element. So what we need to do here is we have to impose a while, that while this 45 is greater than the top of stack, we need to pop that element and then store the value in our answer vector. So first 30 was popped out, and then 35 will be popped out, and then because the stack is empty, so we'll close this while loop if the stack is empty, or if 40 of or if this element is not greater than the top value, and then we'll store this value 45 here, and then we move so on and so forth. So I hope this is clear. Now a very big problem which arises here, and why this question is of the importance that it is because even when we are popping these elements, how do we store the answers in an array? We know the I, that is the index of the present element, but we do not know the index of the element here. Let me tell what I mean. Let me make it more clear what I mean. So our stack was 35 with 30. So our I was 0 here, I was 1 here, I is 2 here, right? So at I equals 2, our element is 45. Now again, we go in our while loop and then we see if this 30 is less than 45, while it is less than 45. So we need to pop it. Okay, not a big deal. We pop this 30 out of the stack. Now in our answer array, let's say we create a vector answer somewhere. So in this answer array, we need to store I, which is the present index, minus I of 30, minus the index of this element. Because we need to, what do we need to store? We need to store the number of elements or the number of days after which a warmer day comes, right? So this is what we need to do. The index of this particular element minus the index of the element which is being popped out. But how do we store the element, the indexes of the elements which are being popped out? And that's why this question is of the importance that it is, as I said previously. So what we will do is we will very cleverly we won't just store this 35 here or this 30 here. What we'll do very cleverly is we will store 35 along with its index, which is 0 here and 0. For 30, we'll store 30 along with with, with its index, sorry, uh, 1, and so on. So we won't have a stack of 8. No, we will have a stack of pair of impermanent. And once we see this pattern, once we realize this, then, well, it's a very smooth sailing. The question is nothing more to offer. So we'll just hop onto our Leetcode window and we'll write the code. Okay, so this is the window and let's try to write it. So let us first declare a stack of pair of s and a vector of int insert. Okay, so we need to traverse through this array. 0 I less than temperatures size plus. Okay, now here if by s dot the stack shouldn't be empty. That's the whole point. and temperature I is greater than s dot top. Obviously, it's a common knowledge that the topmost element in the stack uh, is the smallest element in that stack, and so on. Because had it been larger than the previous element in the stack, that element would have been popped out. So the elements in stack, if we see from the top, it will be in the ascending order. So that's why we can have this condition in the while loop only, and we don't need to check it for each iteration. So what do we do in our okay? So we need to specify the size of this. Very important. And what we do is in our answer s dot top dot first we have to do it because the first element we store is our number and the second element is our temperature and the second element we store is our index. So answer of s dot top dot second, that is the index of that element, will become I minus s dot second, and then we'll pop it. And then the condition that if s sorry if temperatures, I think we should do this condition first, this condition first, that if I is equal to temperature. I'm definitely doing spelling mistakes somewhere. Temperatures of I. So if it's equal, then as we saw, the answer of I 0. This is the condition for our last element. Hence, what we do is because we have to push the element, we just do s dot push and we have to make a pair. We have to make a pair. The first element is the temperature of the day, and then the second element is its index. Okay, so let's have a try through it. Where we have taken a vector for an answer and we return the answer. Is empty temperatures. Okay. Of I is greater than s dot 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 first, answer of s dot 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 second will become this, and s dot this. Also, we had one more condition. S is not equals to empty, that is for all the elements which will remain even after the whole traversal. For all those, answer of s dot of second is to 0, and so yeah, if there are no other um, uh, specified mistakes, that should be good to go. It's accepted, it's submitted, it is accepted. So yeah, the whole point of doing this question was to see this pattern that you can make a pair uh, of integers in a stack in a queue. You can have embedded maps, and these kinds of patterns really help a lot as we go forward in these topics. In hashing also we'll see a lot of these. In the next video we'll see a very good question of queue. And then take care and thank you very much for watching the video.